Hey guys, so just a quick recap of section 4.1, okay? Basically everything we do in stats is based off of samples because we can't usually question our entire population. It would take too much time and money and effort. So we usually get samples. And everything about stats, hopefully we get good representative samples of our population. Otherwise, everything we're doing, we can't really generalize. So the first bad sample we talked about was convenient sampling. Basically, it's just you getting people just around you as opposed to a good representative sample. Usually results in bias. Okay, so like for example, if I go to, for example, a state like Texas and I ask people about their political preferences, I'm probably going to get more Republicans in Texas. If I'm in California and I get a sample of people from California only, I'll tend to get Democratic political preferences. So just getting the people around you, not always the best. You usually get biased responses. If I were to ask you guys in my AP class your GPAs, and I wanted to find out the average GPA of any of all the students at Palmetto, you guys, just being around me, are a convenient sample. You are not a representative, a good representation of the whole Palmetto population, okay? Your responses would be biased because you're going to overestimate the GPAs at Palmetto, okay? So we don't like convenient sampling. They're usually not the best, okay? Another bad sample is voluntary response. So that's usually when you guys choose to be part of the sample. What I mean by that is, for example, like voting for The Voice or American Idol, you choose to text in with your vote, okay? Or, filling out a, 1-star, 5-star review for a hotel. You chose to go on Yelp or whatever and fill out that survey. Usually, these are also not the best because people who tend to participate usually have very strong views. Like if I'm going to rate the hotel, it's not going to be a 3-star review. It's not going to be a mediocre experience that I had. I'm going to rate it because it was terrible or because it was awesome. Okay, so voluntary response, also not the best type of sampling. Our favorite, random. We love random sampling because that means that hopefully we get rid of any bias possible. Okay, so we had 2 ways to do it. I showed you both ways in class. We have using your calculator. Okay, so with this on your calculator, it was, okay, thanks. It was called random integer in your calculator, or it could be random int no repeat. Okay, this is in, there's the math button underneath like second and alpha. You go to math, you go to probability, and then you'll see random int no repeat. Okay, so you could use technology, but remember always step 1, you assign each individual a label. Okay, like a number 1, like if it was your class, let's say your class has 35 kids in it, you'd give everybody a number 1 to 35. 2, you have your calculator or your computer or whatever technology generate however many unique random numbers. So if I needed a sample of 4 kids, I would have my calculator randomly select 4 unique numbers. And the last step is those people who correspond to the selected numbers will be part of the sample. Okay, so no matter how you do it, whether it's calculator or computer or whatever, you always have to mention those 3 steps. Okay, assign people numbers. You have your calculator or whatever randomly select unique numbers, and then people who go with those corresponding numbers will be part of the sample. So you have those 3 steps. Okay, same 3 steps are going to be with if you use the table. So I asked you guys in class to pull out the textbook from under your desk. We looked at the table. Okay, And the way that works, it's kind of the same thing. So it's the same 3 steps. Assign everyone a number, have your table randomly select the however many numbers you need, and then the people who go with those corresponding numbers will be part of the sample. Okay, so we had this example using line 130 from table D. Okay, so we look at the table, it gave us a long list of numbers. Let me scroll down. So it gave us a long list of numbers. So first, we assigned every hotel here a number. So from 01 to 28. Since our biggest number is 2 digits, the first number, and every number has to be 2 digits. So we're going to go every pair. 69 is not in our sample selection, so we're not going to pick it. But 5 is, so that'll be our first number selected. 16 is possible, so that's our second number. 48 is not. 17 is, so that's our third number, and we're looking for 4 hotels. So we just keep going until the 4th number is picked. 17, that's a repeat, so we're not going to pick it. 40, 95, another 17. We're just, again, since we have 2 digits for every value, for every hotel, we're just going to keep going by pairs. And I'm just continuing until I finally get, there we go, one that was within our value. So those would be our 4 hotels that we picked. So again, number 1, assign everybody a number. 2, have the random digits table help us pick the however many, in this case 4 hotels we need. And then those corresponding hotels, so Beach Castle, Radisson, Ramada, and Sea Club, those will be part of the sample. Okay? Sorry. This is the PowerPoint, so I gotta just keep sliding through. Okay, so this was either the last or second to last type of sampling I mentioned. We have stratified random sampling. So strata is just a fancy word for group. And basically what this means is if I think the question I'm going to ask, okay, so let's say I'm asking, I think the one I used in class was, how was your high school experience? If I think freshmen will answer about the same as other freshmen, and seniors will answer the same as other seniors, but I think every grade, like freshmen versus seniors, will answer differently. Okay, if I think the groups will answer differently than each other, I would like to use stratified random sampling. Okay, so basically what that means is, so we have our 9th graders, our 10th graders, our 11th, our 12th. If I need a sample of 100 people, okay, I would then pick a random sample of 25 freshmen, a random sample of 25 sophomores, 25 juniors, and 25 seniors. Okay, the reason being, again, is I think individuals within each stratum, so within each group, are going to answer the same, okay, with respect to what I'm asking. So if I said, again, what's your high school experience? I think 9th graders will answer the same as other 9th graders. I think 10th graders will answer the same as other 10th graders. 11th will answer the same as 11th, and 12th graders will answer the same as 12th graders. But I think there will be large differences between the groups. I think 9th graders will answer very differently than 12th graders. Okay, so this is when you use stratified random sampling. Okay, so random sampling and stratified random sampling are usually like the 2 top ones you like. Random sampling when you think everybody just doesn't matter who you pick, you just need a nice random sample. This one, again, if you think different groups might respond differently, that's when you do stratified. Okay. Now, there are 2 more. So we have cluster sampling. This one, again, with respect to what the population is and what question I'm asking. So if the population, let's say I needed to take a sample of my students, my AP statistics students. Instead of me getting a random sample, and then I get a couple people from 2nd period, a couple people from 4th, from 5th, from 6th, okay, since every class is about the same as each other in terms of, let's say, your GPAs, if every class is roughly the same, instead of me getting a true random sample, I can just pick a cluster, meaning I can just grab one period of AP Stats. Okay, the reason being, if every period is roughly the same, okay, that means each period is a representative sample of the population, so I can just go with one period. So cluster sampling, kind of like convenience sampling, except cluster sampling shows that the individuals in each cluster are heterogeneous. They mirror the population. Okay, convenience sampling, you do not mirror the population, so that's why it's bad. Cluster sampling, again, if I just needed a sample of AP Stats students, I could just pick one whole period because you guys are a representative sample of AP Stats. Okay, and the pros, it saves time and money. Okay, instead of me having to get a couple people from every period and go and find them and then collect the data, I can just do it all in one class period, ask the question, get it over with real quick. All right, and the last type of sampling method is called systematic random sampling. This is the kind where maybe you've seen that, like you've had a teacher do this, where they like start numbering everybody, like they go 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, all my ones, you're gonna do this job. All my twos, you're gonna do that job. Okay, so that's systematic random sampling. That's the idea. Technically, what happens? Let's say I'm gonna pick every 10th person to do whatever job. First, I randomly pick a number 1 through 10, right? So randomly select one of the first K individuals, the 10th, right? And then I choose every Kth individual or every 10th person after that. Usually you'll see this in context where you don't know the total number of people. So let's say, like this example here, it's the exit poll at a polling place for election day. I don't know how many people are going to be voting, so I can't really pick a random selection from those people. Okay, so instead I'll pick a random number 1 through 10. So let's say, I don't know, I pick like 3. And then I pick every 10th person after the third person who comes out of the polling place to ask them how they, like, you know, if they want to respond and how they voted. Okay. People also do it when, let's say it's a big stadium. All right. You don't want to, it's going to take a lot of time and energy to try to truly get a random sample from a stadium of like thousands of people. So instead you get every 50th person as they exit the stadium. Okay, so that's another way to do random sampling. You just pick every however many, like kth person, okay, who comes out. Okay, it could be 10th person, 23rd person, it doesn't matter. Okay, the only thing you have to be careful is make sure there's no pattern in the population. Like, you all know that when your teacher said 1, 2, 3, 1, 2, 3, you saw what number your friend was and you tried to move around so that way you could be the same number as your friend. So we just have to make sure that there's no pattern in the population that coincides with the way you're picking. Okay, because we want it to be an actual like random sample. All right, some issues that come up, okay, with our random sampling is, or just any kind of bad sampling, okay, issues that can come up is undercoverage, which basically means one part of the population is not represented as much as they should. So they are covered in your sample less than they should be. They are undercovered. You have non-response, which is when people are supposed to be in your sample and then they don't respond. So for example, every single one of you was supposed to do the intake survey, and I still have like 3 people who have not responded. You're all supposed to do it. You are all in my sample, in my class, but you didn't do it. So that would be non-response. Okay, meaning you're supposed to answer, but then you don't. And then response bias is just usually when people lie. Okay, that tends to be what it is. People lie or they're a little bit dishonest for a variety of reasons. So, for example, just because it's election season, one of the examples they had before was how Hillary Clinton was predicted to get the presidential nomination in 2016. All the polls said that she should be getting it, and then Trump won. So what happened? Maybe when people were polled, maybe they felt pressured to answer one way and say that they were voting for Hillary when they weren't. Maybe whoever asked the question in such a way that they were confused by what was being asked, and so they answered inaccurately. Okay? So response bias is when, for whatever reason, whether the people are led to answer a particular way or they lie or whatever, it's when the answers are not truthful to what the people actually believe. Okay? Real quick though, we have to be careful. Voluntary response, not the same as non-response. Voluntary response, this is you choose to be in the survey. Okay, you volunteered to do it. You don't have to be in the survey. Okay? You just volunteered to do it because you felt like it. You weren't supposed to be in it to begin with. Again, you chose to do it. Non-response, you are in the sample. Like, that's a non-starter. You're supposed to be in it. Just like you guys are in my class and you were supposed to do the intake surveys. You are in the sample. And you failed to respond. Okay, there's a difference. In voluntary response, you weren't in it to begin with, so if you don't answer, that doesn't matter. Okay, you chose to then answer and be in the sample and be in the survey. Non-response, you are in it. You are supposed to be in the sample. Okay, if they were doing a survey of teachers and they needed to know if we should go from 6 periods to 8 periods, I am in that sample. I need to answer that. If I don't, that would be non-response. Okay, so if you are in the sample and you fail to respond, that's non-response. It's very different. Again, voluntary, you chose to be in it. You didn't have to. Non-response, you are in it and you're supposed to answer, but you don't. Okay, so I just wanted to do a real quick recap of 4.1 and go over the last little bits that we didn't get to go over in class. And so please don't forget to check Schoology and look at the problems that are assigned to you so you can do the work for 4.1 while I'm not here. All right, I will see you guys next week. Bye.